Every day, millions of Americans open their refrigerators, pull out yesterday's dinner, place it in the microwave, press a few buttons, and assume they're making a perfectly healthy choice. After all, reheating leftovers saves time, reduces food waste, and fits easily into busy lives. It seems harmless. But what if I told you that for two very common foods, the real concern isn't the first time they're cooked, it's what happens after they've been stored and reheated? The changes are invisible. You can't smell them. You usually can't taste them. Yet inside those foods, heat can trigger chemical reactions that researchers have been studying for decades. Some of those changes involve compounds that, under certain conditions, have been linked to DNA damage, chronic inflammation, or other biological processes associated with cancer development. Now, before you panic and throw away every leftover in your refrigerator, let me reassure you. This video is not about creating fear. It's about understanding the science so you can make better decisions for yourself and your family. My name is Dr. L. Weisbrock, and for more than 30 decades, I have helped people better understand nutrition, metabolism, and chronic disease prevention. Throughout my career, I've learned that many of the most important health risks don't come from dramatic events. They come from small habits repeated day after day, year after year. Today, we're going to examine two foods that many people reheat without a second thought. Both are considered healthy. Both are found in millions of American kitchens every week. Yet researchers have discovered that under certain storage and reheating conditions, these foods can undergo chemical changes that deserve a closer look. One of them is especially surprising because it is commonly recommended as part of a healthy diet. So stay with me until the end, because understanding why these changes happen is even more important than simply knowing which foods they involve. And if you enjoy evidence-based health information explained in plain English, consider subscribing to the channel. Every week, I break down complex medical research into practical advice you can actually use in everyday life. Before we discuss the foods themselves, we need to understand something that almost nobody talks about. Food does not stop changing the moment you finish cooking it. Most people imagine that once dinner is cooked, the food simply waits in the refrigerator until it's reheated. In reality, countless microscopic reactions continue long after the stove has been turned off. Oxygen continues interacting with fats. Natural enzymes continue working. Tiny amounts of moisture move through the food. Even under refrigeration, certain bacteria can slowly multiply if food isn't cooled and stored properly. Think of cooked food like a freshly cut apple. The moment you slice it open, the surface slowly begins turning brown. That change doesn't happen because the apple suddenly became unsafe. It happens because oxygen begins reacting with compounds inside the fruit. Cooked foods experience something similar. Some changes are completely harmless. Others slightly reduce flavor or texture. But under certain circumstances, especially when foods rich in protein or naturally occurring nitrates are stored improperly and then reheated at high temperatures, researchers have observed the formation of compounds that deserve attention. One of the most important processes is called oxidation. That sounds technical, but the idea is actually simple. Imagine leaving a bicycle outside in the rain. Over time, metal begins to rust because oxygen reacts with the surface. A similar process can occur with fats inside food. Instead of rust, fats gradually become chemically unstable. When those already unstable fats are exposed to heat again, they can break apart into smaller molecules. Some of these molecules are harmless. Others, including compounds such as malondialdehyde, have been widely studied because laboratory research suggests they may damage cells under certain conditions. Another important process involves compounds called nitrosamines. You've probably heard this word before in discussions about processed meats. Nitrosamines don't simply appear out of nowhere. They can form when nitrites interact with certain proteins during cooking or digestion. Some nitrosamines are classified by the International Agency for Research on Cancer as probably or known carcinogenic under specific exposure conditions. That does not mean every meal containing nitrates or nitrites causes cancer. Dose matters, frequency matters, overall dietary pattern matters. Researchers continue studying exactly how much these compounds contribute to long-term cancer risk in real-world diets. That distinction is incredibly important. One of the biggest problems with health information online is that it often jumps from laboratory findings directly to frightening conclusions. Science doesn't work that way. Researchers gather evidence piece by piece. Laboratory experiments help identify biological mechanisms. Animal studies explore how those mechanisms behave in living organisms. Human observational studies examine patterns across large populations. Randomized clinical trials answer other important questions. Only after many different types of evidence point in the same direction do public health recommendations begin to change. Throughout this video, I'll tell you not only what researchers found, but also how strong that evidence actually is. Because understanding uncertainty is part of understanding science. Now let's turn to the first food. It probably isn't what you're expecting. It isn't bacon. It isn't sausage. It isn't fast food. It's a vegetable that nutrition experts have recommended for decades. Spinach. Few foods have earned a healthier reputation. Rich in folate, vitamin K, magnesium, iron, and antioxidants, spinach has been associated with numerous health benefits. Large population studies consistently show that diets rich in vegetables are linked with lower risks of cardiovascular disease and several chronic illnesses. So why would anyone suggest being cautious about reheating it? The answer has nothing to do with spinach itself. The concern begins after it has been cooked, stored, and then reheated. Spinach naturally contains relatively high amounts of nitrate. That sounds alarming, but it shouldn't be. Natural nitrates found in vegetables are very different from the preservatives commonly added to processed meats. In fact, dietary nitrates from vegetables can help support healthy blood vessels and normal blood pressure. That's one reason leafy greens remain an important part of a balanced diet. But here's where things become more interesting. After cooked spinach sits in the refrigerator, naturally occurring bacteria can gradually convert some nitrates into nitrites. That process alone doesn't automatically create a health hazard. However, when nitrites are exposed to certain cooking conditions or interact with proteins under acidic conditions in the stomach, they may contribute to the formation of nitrosamines. Researchers have been studying this pathway for decades. Some nitrosamines are well-established carcinogens in laboratory settings. Human evidence is more complex because overall diet, smoking, alcohol use, obesity, genetics, and many other factors all influence cancer risk. Still, scientists generally recommend minimizing unnecessary exposure whenever practicable. Imagine preparing a large pan of cooked spinach on Sunday evening. You refrigerate it. On Monday, you warm part of it. Tuesday, you heat it again. Wednesday, you microwave what's left for lunch. Each reheating cycle exposes the food to additional heat, while chemical changes continue during storage. Does that mean you've guaranteed illness? Absolutely not. but current evidence suggests repeatedly heating nitrate-rich vegetables offers no nutritional advantage and may increase the opportunity for certain unwanted chemical reactions. Fortunately, the solution is remarkably simple. Cook only the amount you expect to eat. If you have leftovers, refrigerate them promptly in a shallow container so they cool quickly. When possible, enjoy leftover spinach cold in a salad or wrap rather than reheating it repeatedly. Better yet, prepare smaller, fresh batches. Not because spinach is dangerous, quite the opposite. It's because spinach is one of the healthiest vegetables you can eat when handled properly. Unfortunately, many people misunderstand this point. They hear headlines claiming that reheated spinach is toxic or causes cancer. Current scientific evidence does not support such absolute statements. Instead, what the evidence suggests is much more nuanced and ultimately much more useful. Proper storage matters. Repeated high-temperature reheating may not be ideal. Fresh preparation is generally the better choice. That is a far more accurate reflection of the science. And if you think that was surprising, the second food may surprise you even more. Unlike spinach, this next food appears in nearly every meal prep container across America. It's recommended by doctors, fitness coaches, and dietitians alike. Yet repeated reheating changes it in ways that many people have never heard about. The second food is one that surprises almost everyone: chicken. If you ask nutritionists to recommend a healthy source of protein, chicken is almost always near the top of the list. It's lean, it's high in protein, it's versatile. And for millions of Americans trying to lose weight, build muscle, or simply eat healthier, grilled chicken has become a weekly staple. Many families cook several chicken breasts on Sunday afternoon, divide them into meal prep containers, and reheat them throughout the week. It's convenient, it's affordable, and in many ways, it's a smart habit. But here's what many people never think about. What happens to chicken after it has already been cooked once, cooled, stored, and then exposed to high heat all over again? The answer isn't as simple as you might expect. Before we go any further, I want to make something very clear. Cooking chicken thoroughly the first time is absolutely essential. Proper cooking destroys harmful bacteria like Salmonella and Campylobacter that can cause serious foodborne illness. The concern we're discussing today isn't about safely cooking raw chicken. It's about what repeated heating may do to the proteins and fats already present in cooked meat. These are two completely different issues. Once chicken is cooked, its proteins unfold and change shape. That's a normal part of cooking. But when cooked chicken is repeatedly exposed to high temperatures, researchers have found that additional chemical reactions begin taking place. One of those reactions involves compounds known as heterocyclic amines. The name sounds complicated, but the idea is actually simple. When muscle proteins and certain natural substances inside meat are exposed to very high temperatures, new compounds can form. Scientists have studied these compounds for decades because in laboratory experiments, some have shown the ability to damage DNA. DNA is the instruction manual inside every cell of your body. When DNA becomes damaged repeatedly over many years, mistakes can accumulate. Those mistakes are one part of the complex process involved in cancer development. That doesn't mean eating reheated chicken causes cancer. It doesn't. Cancer develops through many different factors, including genetics, age, smoking, alcohol, obesity, physical activity, environmental exposures, and overall dietary patterns. However, researchers continue investigating whether long-term exposure to higher amounts of certain cooking-related compounds may contribute to cancer risk. Organizations like the National Cancer Institute have explained that heterocyclic amines form primarily during high-temperature cooking methods, such as grilling, pan frying, or broiling. The darker and more heavily browned the meat becomes, the greater the formation of these compounds tends to be. Now imagine this situation. You grill chicken on Sunday until it develops a dark, flavorful crust. On Tuesday, you microwave it until it's steaming hot. On Thursday, you toss it into a skillet to warm it again because the microwave made it rubbery. Each reheating cycle exposes that already cooked protein to additional heat. Researchers are still studying exactly how much repeated reheating changes the concentration of these compounds, but food scientists agree that minimizing unnecessary high-temperature reheating helps reduce additional chemical changes. There's another reason scientists pay attention to reheated chicken: fat oxidation. Even lean chicken contains fat. When oxygen interacts with those fats during refrigeration, slow oxidation begins. You can think of oxidation as a form of gradual wear and tear. Then, when the chicken is heated again, that process accelerates. Some oxidation products, including compounds like malondialdehyde, have been widely studied because laboratory research suggests they may contribute to oxidative stress. Oxidative stress simply means there's an imbalance between harmful molecules called free radicals and your body's natural defenses. Over time, excessive oxidative stress has been linked to inflammation and many chronic diseases. Again, it's important to keep this in perspective. Our bodies are remarkably equipped to handle a certain amount of oxidative stress every single day. The concern isn't one reheated chicken breast, it's repeated exposure over many years combined with other lifestyle factors. This is why researchers focus on overall eating habits rather than isolated meals. Let's imagine a retired couple. Every Sunday, they prepared 12 grilled chicken breasts for the week. By Friday, the last portions have been reheated several times because plans changed, meals were skipped, or leftovers kept getting returned to the refrigerator. They're trying to eat healthy. They're doing what countless experts recommend by preparing balanced meals ahead of time. But a few simple adjustments could make those meals even better. Instead of reheating the same chicken over and over, prepare smaller portions. Only warm what you'll actually eat. Use gentle heat whenever possible instead of blasting it at the highest microwave setting. If the chicken will be eaten cold in a salad or wrap, that's often another practical option. The goal isn't perfection. The goal is reducing unnecessary exposure while still enjoying nutritious foods. And this brings us to one of the biggest misunderstandings in nutrition. People often assume that if a food starts healthy, it stays exactly the same no matter how it's stored or reheated. Food chemistry doesn't work that way. The nutrients don't suddenly disappear, but heat, oxygen, and time can slowly change certain components inside many foods. That's why storage methods matter. That's why cooking methods matter. And that's why scientists continue studying what happens after food leaves the stove. So, does this mean you should stop eating chicken? Absolutely not. Chicken remains an excellent source of high-quality protein, vitamins, and minerals. The message isn't to avoid it. The message is simply to cook it safely, store it properly, avoid repeated high-temperature reheating whenever possible, and enjoy it as part of an overall balanced diet. Those small habits can make a meaningful difference over the long term. Now, if you thought chicken was surprising, the final food on today's list may challenge something you've believed for years. It's found in nearly every American refrigerator. Millions of people eat it almost every morning, and very few realize that the way they reheat it may change far more than its texture. Let's take a closer look.